Welcome to Brain Vision.
Let's use the chain rule to find some partial derivatives. First of all, by using the first equation, you see that z just depends on two variables, x and y. And then you see x and y each depend on two variables, s and t. You see that from the last two equations here. So I'll go ahead and draw that tree diagram to help us out with the formula for the chain rule. So derivative of z with respect to t. So using the tree, how do we go from z to t? You can go from zx and then x to t, that's one way. So let's write that out. So dz over dx dx over dt, and then we could also get there by using dz dy and then dy dt. So let's just go ahead and use our formulas to simplify these. So the first one is the derivative of z with respect to x. So we'll go ahead and use the chain rule here. So that'll be 1 over 1 plus the expression inside the arctan, and that gets squared. And then by the chain rule, in the numerator, we'll have to multiply by the derivative of x squared plus y squared with respect to x, and that is just 2x. Up next, we have derivative of x with respect to t. We see that this is just s over t. Going on to the next one, derivative of z with respect to y. We already differentiated this arctan, and using a similar argument as our first term over here, this one will be 2y over 1 plus x squared plus y squared in parentheses squared. And then finally, derivative of y with respect to t. Use this formula up here, and we'll go ahead and then we'll get an e to the s power. And so we can stop right there. That's one of our derivatives. So let's just go ahead and circle this part off. First answer. And we have one more to go. We also need the derivative of z with respect to s. Should have did this one first. So using the tree again, you can go from z to x and then x to s, or z to y and then y to s. So very similar to the previous case. And then now we'll go ahead and evaluate these, and actually two of these derivatives, I'll put these in parentheses. We've already computed these in the previous line, so we already know what those derivatives are. Derivative of x, this time with respect to s, that'll just be ln t. Derivative of z with respect to y, we already have that from the previous line. And then derivative of y with respect to s, and that is just te to the s. So we've used the chain rule twice, and then we use the given formulas to evaluate all the extra partial derivatives. So these are our two answers.